And here we go, the last part concerning the sense of variation of functions. Here is example 7. We have this curve of a certain function. This curve is decreasing till it reaches the minimum, then it is increasing. And let's study the sense of variation of such function using the table of variation. As I told you every time, here is x and here is for f of x. Now, why did I put here minus infinity and plus infinity? Because the curve is not bounded by points, not limited by points. Then I suppose that, or I claim that, the domain of definition is from minus infinity till plus infinity, which is this set R. So I have now to care about the value along the x-axis where change takes place. What's this value? Let's see here. From minus infinity till, we move along the x-axis from the left to the right. From minus infinity till 3, there is a change till 3 because it's decreasing. When it reaches 3, it starts increasing. So the value I care about along the x-axis is 3. And here is the column for 3. Now I have to distribute the arrows using the curve. So decreasing from minus infinity till 3, then I represent it by a decreasing arrow. And from 3 till plus infinity, it is increasing, so I represent it by an increasing arrow. Now what should be put here? At minus infinity, the curve is moving from up to down, moving downward. So what is up? It is plus infinity. When it reaches 3 along the x-axis, the value here must be the ordinate of 3. What's the ordinate of 3? As I told you every time, we have to project along the curve, then along the y-axis, and the value here should be minus 2. Okay, so the value here is minus 2 and the value here is plus infinity. So it's decreasing from plus infinity till the minimum minus 2, and then it goes up till plus infinity. Okay, now this value minus 2 is called the minimum because it's like a valley, decreasing then increasing. Okay, and the coordinates 3 minus 2 are the coordinates of the minimum point. 3 is the abscissa and minus 2 is the ordinate. And here is the last example, example 8. Here is another curve that's going up, then down, then up. Okay, and also this curve is not bounded, it's not limited by points. Then I claim that its domain of definition is from minus infinity till plus infinity. Okay, so I put minus infinity and plus infinity along these columns. X here is and f of x is here. Then I have to spread the abscissas that I care about between minus infinity and plus infinity moving along the x-axis. And let's start. From minus infinity till minus 2, the curve is increasing. So I move along the x-axis. From this part till minus 2, the curve is increasing and the change starts to occur at minus 2. When I reach minus 2, this starts decreasing. Then when I reach 0, it starts increasing. Then the points or the values along the x-axis that I care about are minus 2 and 0. Okay, so here is for minus 2 and this column is for 0. Again, I have to distribute the arrows from minus infinity till minus 2. The curve is increasing, so I make an increasing arrow. Between minus 2 and 0, this part, look at this part between minus 2 and 0, the curve is decreasing, so I represent it by a decreasing arrow. And from 0 till plus infinity, the curve is increasing, so I represent it by an increasing arrow. Now I have to distribute the values here. At minus infinity, the curve is going up along the y-axis, okay? From what here down? What do we have here? We have minus infinity till it reaches the maximum. What's the maximum for this function? It's clear here. It is 4. So the ordinate of minus 2 is the maximum for this function, which is 4. Now the ordinate of 0 is the minimum for this function, which is 0. Okay? And as we go like this, the function is going up, and what's up? It is plus infinity. And here is the completed table. Now this 4 represents the maximum. As I told you, the minus 2 for the point, the coordinates of the point that are minus 2, 4 are for the maximum point, and 0, 0 is called the minimum point. In general, we call them the extrema in plural, extremum in singular. So when I talk about an extremum, it's either a minimum or a maximum. Okay? So extremum is for the singular maximum or minimum, and extrema is for the plural. And sometimes you are asked to specify the extremum, then you have to specify if it is a maximum or a minimum using the figure. If it's like this, like a mountain, it's called a maximum. And if it's like this, like decreasing then increasing, it's clear. Okay, either using the arrows, you can see it by increasing then decreasing, then thus it is a maximum. Okay, or using the curve, you can see that it's like a mountain or a peak, we call it a maximum. And if it looks like a valley, okay, or using the arrows, it's decreasing then increasing, it's very clear that it is a minimum.